this diagram explains us the operation of a transistor. So this is an NPN transistor. So this is N, this is P, and this is N. So there are three layers of a material. A P is sandwiched between two N type of materials, so that's why it is NPN transistor. Now look at the voltage sources, those are connected. So that's the first voltage source, it is called as VBE. So that's the voltage source connected between base and emitter, that's why we call it as a VBE, where positive of it is connected to the base. Right here you see this base, and the negative terminal of this battery is connected to the emitter right over here. So you, with this, positive is connected to the P type of semiconductor and negative is connected to the N type of semiconductor. So this makes the junction, or this PN junction, this makes this PN junction forward bias. With that said, let's focus on the another voltage source where we see that it is called as VCB. So that's the voltage connected across collector and base of this transistor. So the positive is connected to the collector and the negative is connected to the base. That's why we call it as a with this arrangement, we see that the positive is connected to the N type of material and negative is connected to the P type of semiconductor. So this makes the junction a reverse bias. So your collector and this voltage source is called as VCB because it is connected across collector and the base. So when this junction right here is forward bias and this junction is reverse bias, so that's the biasing condition of a transistor, where you bias the transistor to operate in an active region. So with this arrangement you can make the transistor work as an amplifier because it is biased in an active region. It will work linearly. Now let's have a focus on the circuit. So you have this current right here. The collector current is flowing inside as shown over here with the IC, and the current that is coming out is emitter current, that is IE, and there is some current going inside the base of this transistor is called as base current, and the IE is the sum of two current, that is IB plus IC. Now from physics point of view, we'll say that the flow of electrons is the opposite of that current, or the direction of current is the opposite to the flow of electrons. So you see this arrow indicates the electrons flow from emitter towards the collector, and some part of it, some portion of that total emitter electrons recombine with the holes in the base region. So that's why this arrow downwards indicates that. So all electrons trying to go to the collector region, some electrons will recombine with the holes in the base. So that process is called as recombination. Alright, and in terms of current, we'll see this with the positive arrow, a small arrow. This arrow will represent in another way, that's the current, base current. So this figure explains you the operation of your NPN transistor biased in an active region.